I'm Dave Peitzman, DJ Technologies. I'd like to show you a 5-gas engine emissions analyzer we've developed for biodiesel and alternative fuels research. This analyzer will measure HC, CO, CO2, O2, and NOx. Plus it has 5 additional inputs on there for sensors of your choice, and it can be customized to the application. It's a PC-based instrument. All the data is saved in an Excel format. We've got it packaged in a military-style Pelican case, and it has wheels, and it has a collapsible handle, so it's very good in a portable application. Let's open it up and I'll show you how it works. As you can see, it's totally self-contained. The laptop is in the top of the case, and the analyzer, electronics for the analyzer, is down in the lower section. We'll come in and take a closer look at it. This one in particular is running on a Dell laptop. It's run on XP. We're going to be concerned with 3 icons. First icon here is the COM check icon. That's strictly utility to make sure that the computer and the gas analyzer are talking to one another. And the icon in the middle, this is the one that actually starts the analyzer. And the one here, this is the one that gets us into the Excel format, and we can look at our test results data. I'll come up here and click on this icon. We go straight to the gas analyzer program. Once you get to the blue screen, why, you completely forget about the touchpad or the mouse. This program is keyboard controlled. The searching eyeballs down in the lower corner, that was the weight indicator. We'll jump right into the program. I'll select number 2, which is the data logger. We have here the entry on the data screen. This is the duration. You can set an automatic shutoff from 5 seconds up to 3 hours, or if you have a long-term test, we put 4 nines up here in the duration. I'll put 4 nines in here, and when you select 4 nines, you've automatically override the automatic shutoff, and this will collect data until you tell it to stop. We'll hit enter. Then it's asking us for the interval. The interval is the rate at which it saves data to the hard drive. This is selectable from every second out to every 15 minutes. If you're doing research, you may want to select every second, because this gives you some really nice graphs in Excel, because you've got a lot of data points. In this particular case, I selected an interval of 6, which will give us 10 readings every minute. We'll hit enter again. This takes us down to the file name, and I'll put in 5-gas. Also, when you enter your file name, if you've got a file on your hard drive with the same name, the new file is not going to overwrite the old file. You can save multiple files by the same name. They will append to one another. We can continue to go down and add additional data. You can do a name and address and for your client. This is for hours. Ignition type sets the pulse counter. There's a pulse counter in here, and we want that on 2 cycle, because that gives you real-time data on the pulse counter. We'll hit enter one more time. We have 3 lines of comments. There's 35 spaces per line. This gives you the opportunity to specifically identify your test, say engine size or whatever whatever data you want to include with your test. It's not necessary to go this far. Once you've completed the file name, you can bypass this information by using page down, or if you want to include the information, it's purely up to you. Page down advances you onto the actual gas analyzer screen. It's going to ask us where we want to put the data. In this case, we're going to do it on the hard drive. If we would have had a file in here by this previous name, in this case I used 5-gas, if we would have had another file in there by the 5-gas name, we would have had a flag that would have said, file exists, this new data will be appended to the old data. Once we get on the data logger screen, the analyzer goes into a zero mode. This is where we're pumping fresh air through the sample chamber and establishing a reference. This zero cycle takes 2.5 minutes. Okay, the analyzer has come out of the zero cycle and it's all ready to measure gas. The data here on the bottom of the screen, this is the data from your expansion ports. I've got a pulse counter hooked up to RPM. Turn that on. And on input 1, got a battery. The data here has adjustable decimal points. We can change the decimal point depending upon whatever sensor you choose to hook up to this. Also, the titling on these inputs, on these expansion ports, these can also be changed too. We also have a temperature sensor up here. This is a K-type thermocouple. I'm using a Omega module, and this is for exhaust temperature. And I think it maxes out about 2,300 degrees. And as you can see, it works quite well and rather quickly. All of this data that's on here, your gases and all the data from the expansion port, this becomes part of the original data file that is filed in the Excel format. Another quick test to make sure that the analyzer is working, using the Bic lighter again. Flick the Bic on the sample hose, and there's our hydrocarbons. We hook this up to a calibration tank and we'll put some gas in it. Okay, I've hooked this up to a calibration tank. We'll open the valve. We've also turned off the pump. You may have some cases where, particularly in research, where you do not have enough, simply don't have enough gas to run the pump. Incidentally, the pump runs at about 4 liters per minute. You may not have enough gas to give you 4 liters a minute, and the pump can be turned off. The analyzer could be hooked up to a different pump, or if the gas you're sampling happens to be under pressure, you can turn the pump off and flow the gas through the analyzer and collect your data that way. We'll start the recorder here by hitting F1. And as you can see, in this upper corner, it tells us, starts to count off the number of recordings that we have. We're actually creating a file right now. I'll give it just a little bit more gas. As you can see, when oxygen drops to 0, we'll have pure calibration gas in there. In the meantime, I'll hit the pump and we'll purge it. Okay, now we'll exit the program. We'll go back to the data file. See what we have. Escape always backs us up. We hit number 4 to exit the program. We're back on the desktop, and we'll go up in here to the gas data file and take a look at the test that we just did. There's our file, and there's our data. As you can see, we have the gases that we measured. There's the information from the pulse counter. Also, on each gas entry on Excel, you have a time and you have a date stamp, and this applies to all the data that's on here. This is the data from the expansion port, the battery voltage. Anyway, that pretty well covers the gas data information. Let's go back into the actual program, and we'll take a look at the calibration menu. Here we are back on the desktop. We'll restart the gas analyzer program with that icon. There's our blue screen. There's our weight indicators down here. The analyzer will go through the zero cycle. Since it's already warmed up, why, it's not going to take 2.5 minutes this time. The calibration menu, but the calibration feature is part of the maintenance menu. To enter the maintenance menu from the main menu, you hold down Alt and hit M. This will take roughly 15 seconds for it to maintenance menu to pop up. There's our maintenance menu. Gas calibrating the bench is the first option. We'll hit Enter. We will select one step for the calibration. This is where we enter our gas values that are on our tank. These gas values here are based upon 10,000. For instance, on CO2, I've got 600 entered here. 600 is 6% of 10,000. On higher levels of gas, say for instance you had a 12% carbon dioxide tank, you would enter 1200. Also, if you want to calibrate this using single gas as opposed to a blend, put zeros in the gases that you do not have or the gases that you don't want to use, and the calibration menu will completely ignore anything that has a zero in it. Make sure that the values that you have in your menu certainly match the calibration values that you have in your tank. We'll do an enter and a page down, and it's going to go into another zero cycle. During this zero cycle, make sure you do not have the calibration tank opened on the analyzer. You do not want to open your calibration valve on your tank until prompted by the flag on the screen. I believe this one will go through another 2.5 minute zero cycle. Okay, the analyzer's come out of its zero cycle. We have our flag here that says open calibration gas valves and press any key to continue. You do not want to open your calibration tank until you get this flag. Open the valve. And we'll hit enter. Now this flag says checking calibration gas. After the checking calibration gas flag, we go on to the next flag, which says calibrating the analyzer. And finally we get the flag we've been looking for, calibration passed. Incidentally, when during every calibration cycle, after you're finished, or after it's finished, it puts a calibration report on the hard drive in the gas analyzer file. So you have a record of all of your calibration gases, and it certainly will tell you whether you pass or whether you fail. If it fails, more often than not, the value on the tank is different than the value in the calibration menu, or you may have put a zero, may have failed to put a zero into a gas that you didn't have. But anyway, before we back completely out of here, I want you to see the regulator that I'm using on this. These 12-inch birthday balloons on a T-fitting just make dynamite regulators when you calibrate an analyzer. Okay, I just hit enter. This takes us out of the actual calibration mode. At this point, make sure that you have shut off your calibration tank and disconnect the gas source from the analyzer. I think that pretty well covers the operation of this analyzer. This is an infrared system. Keep in mind the infrared analyzers completely isolate the detectors and the IR sources from any of the sample gas. That's the way you get they're a lot more rugged, a lot more reliable. If you have a case of contamination or you get water contamination, the sample chamber can actually be removed, it can be cleaned, it can be put back together, and this is something that you can do out there in the field, as well as calibrating. I think previously here you were able to see that the calibration is fairly simple and fairly straightforward. So anyway, appreciate you taking the time to watch this video. If you have any questions or comments on it, please get back with me by email at dj@earthlink.net. That's DJ, D-E-J-A-Y-E @earthlink.net. I thank you for watching. I'm Dave Peitzman, DJ Technologies.